For generations, humanity believed it had uncovered the grand story of the cosmos. The equations seemed elegant, the timeline appeared clear, and the birth of the universe was thought to be understood. But far beyond Earth, nearly 1 million miles from our planet, a revolutionary observatory has begun revealing a very different picture. The James Webb Space Telescope was designed to look deeper into space than any instrument before it. Yet, what it has uncovered is not merely distant, it is unsettling. Each image appears to raise a profound question. What if the universe is far older, far stranger, and far more complex than our current theories allow? What if some of our most cherished assumptions about cosmic history are incomplete? Among Webb's most astonishing discoveries is a distant galaxy known as MAC 0416-Y1. This remarkable object is being observed as it existed when the universe was only a tiny fraction of its current age. And yet, despite its youth, it already displays signs of surprising maturity. Within it, astronomers have detected evidence of dust, heavy elements, and intense star formation, ingredients that should have taken far longer to emerge according to traditional models of cosmic evolution. The discovery has forced scientists to confront an extraordinary possibility. Perhaps the early universe evolved much faster than anyone imagined. Or perhaps there are chapters of cosmic history that we have yet to understand. These revelations strike at the heart of cosmology itself, the science devoted to explaining how everything began. If galaxies like MAC 0416-Y1 could form, mature, and enrich themselves with heavy elements so quickly after the dawn of time, then our timeline of the universe's infancy may need significant revision. And this is only the beginning. From the moment Webb opened its golden mirrors to the cosmos, it began delivering surprises. Its powerful infrared instruments pierced through the veil of time, allowing astronomers to witness regions of the universe that had remained hidden for billions of years. What researchers expected to find were primitive galaxies, small, chaotic collections of newly formed stars still struggling to assemble themselves. Instead, Webb revealed something entirely unexpected. Scattered throughout the distant universe were enormous galaxies, surprisingly structured and remarkably developed. Some appeared far too massive, far too bright, and far too organized for an epoch so close to the supposed beginning of cosmic history. It was as though archaeologists had uncovered a modern city buried beneath the foundations of an ancient village. And then, the mystery deepened. A research team led by Pablo Perez Gonzalez identified a collection of enigmatic light sources near the very edge of the observable universe. Several of these objects appeared at astonishingly high redshifts, placing them within the first few 100 million years after the Big Bang. To understand why this matters, we must understand redshift. As space expands, light traveling through the cosmos stretches along with it. The greater the stretch, the distant and older the source appears. Looking at extreme redshifts is like looking through a time machine, allowing us to witness the universe in its earliest moments. Some of these newly detected sources appear to originate from an era that was once believed to be almost entirely dark. According to conventional models, the young universe spent millions of years emerging from its fiery beginnings. Following the Big Bang, space was filled with an intensely hot plasma. Only after sufficient cooling could atoms form, allowing light to travel freely across the cosmos. The ages that followed became known as the Cosmic Dark Ages. No stars illuminated the heavens, no galaxies decorated the darkness. The universe was vast, silent, and almost completely devoid of visible light. At least, that was the expectation. Yet Webb's observations hint at something very different. Instead of emptiness, astronomers are finding evidence of brilliant sources shining across this ancient landscape. Light appears to be emerging from a time when darkness should have ruled the cosmos. These objects do not fit neatly into existing categories. They are not ordinary stars, they do not resemble familiar galaxies. In fact, if current theories are entirely correct, some of them should not be visible at all. And that leaves scientists facing one of the most fascinating mysteries in modern astronomy. What exactly are we seeing? One possibility is as dramatic as it sounds. Some researchers suggest these objects may be linked to primordial black holes, ancient relics that could have formed fractions of a second after the birth of the universe itself. If ordinary stellar processes cannot explain the extraordinary brightness being observed, then an entirely different engine may be at work. Primordial black holes, feeding on surrounding matter and releasing enormous amounts of energy, could potentially illuminate regions of the young cosmos long before conventional stars and galaxies were expected to appear. If true, the implications would be staggering. It would mean that some of the first structures in the universe were not stars, but black holes. It would reshape our understanding of how galaxies formed, how matter assembled itself, and perhaps even how the universe evolved during its earliest moments. And as Webb continues its mission, discoveries like MAX 0416Y1 and these mysterious ancient light sources are forcing scientists to reconsider questions once thought settled. Not because our theories have failed, but because nature, once again, appears to be more imaginative than we ever dared to believe. If that's true, the implications are staggering. Decades ago, Stephen Hawking suggested that primordial black holes might not only illuminate the universe's first moments, but could even act as gateways, portals to other universes entirely. And that's not the only cosmic curveball Webb has thrown at us. Astronomers have also found strange objects they've dubbed little red dots. At first, they were thought to be tiny, compact galaxies, but follow-up data blew that theory apart. These things don't behave like galaxies at all. Now, a radical new idea is emerging. These could be black hole stars, something unlike anything seen in today's universe. Imagine this. A massive early star collapses. A black hole forms at its center, but instead of devouring the entire star, the outer layers remain intact. The result? A bizarre hybrid, a star powered by a black hole heart, blazing with unimaginable energy before finally collapsing for good. If that's real, Webb may be catching a glimpse of a cosmic stage once thought impossible to witness. And the deeper Webb looks, the more unsettling it becomes. Some of its latest data suggests the expansion of the universe itself might be slowing down. For decades, scientists believed expansion was speeding up, driven by a mysterious force called dark energy. But Webb's findings hint at something far more complex, regions of the universe expanding at different rates, as if dark energy isn't uniform after all. If that trend continues, the universe's expansion could one day stop and even reverse, ending in a cataclysmic big crunch where everything collapses back into a single fiery point. And all this comes on top of the problems astronomers were already struggling with. The so-called Hubble tension, showing the universe expands faster nearby than expected from early data, and the S8 tension, revealing galaxies clump less than models predict, were already deep puzzles. And now, Webb's discoveries aren't just adding to the mystery, they're making it impossible to ignore. And then comes the most mind-bending discovery of them all. When scientists analyzed the spin of more than 30,000 galaxies, they found something that shouldn't be possible. Most of them were rotating in the same direction. According to everything we know from the Big Bang model, the early universe should have been pure chaos, galaxies spinning randomly, no order, no pattern. But Webb's data tells a different story. Even more shocking, the farther back astronomers looked, the stronger that cosmic alignment became. In the universe's earliest moments, galaxies weren't random at all. They were synchronized, almost as if following some hidden rhythm written into the fabric of space itself. And that's where things take a truly wild turn. What if the universe itself is spinning? It sounds impossible, but what if the cosmos isn't perfectly uniform and directionless as we've always believed? What if there's a subtle rotation woven into reality itself? If that's true, then the entire framework of modern cosmology is missing something huge. Every model built on the assumption of a perfectly still, isotropic universe would need to be rewritten. And here's where it gets even stranger. If the universe does have a spin,
even a tiny one, it could mean we're living inside something far more mysterious. Some scientists are now entertaining a radical idea. What if our entire universe exists inside a black hole? Picture this: the universe didn't explode outward from a single point in a neat, clean Big Bang. Instead, it might have been born inside the event horizon of a massive black hole that formed in a larger, unseen reality beyond our own. From our perspective, that event horizon would look like the edge of the cosmos itself, the ultimate boundary, the point beyond which no light, no information, no signal can ever escape. Everything we know, the galaxies, the stars, the light itself, exists inside this vast cosmic boundary. And beyond it, in a realm forever hidden from our instruments, could lie something even more extraordinary: the parent universe that collapsed and gave birth to our own. Recently, researchers at the University of Portsmouth have proposed a bold new idea to explain this. They suggest that our universe didn't just pop out of nowhere in a mysterious singularity. It might have been born from the death of another universe. According to their model, that earlier cosmos collapsed under its own gravity, crushing matter to unimaginable density, warping space-time to its limits, and then rebounding. The result? An explosion outward that we now call the Big Bang. In this view, the Big Bang wasn't the beginning of time, but the next chapter in an ongoing cosmic cycle, a bounce from one universe to the next. It replaces the mystery of something emerging from nothing with a continuous chain of cause and effect. And if that sounds unsettling, that's because it is.
It means the foundations of modern cosmology, the ideas we've treated almost like sacred truths, might not be as solid as we thought. Dark matter, once seen as the invisible glue holding the universe together, is under serious scrutiny. Dark energy, long believed to be the steady force driving cosmic acceleration, may not be constant at all. Even the Big Bang itself, the most iconic event in science, could turn out not to be the beginning but just one phase in an endless cycle of creation and collapse. And the cosmic microwave background, the faint afterglow we've always believed was the leftover light from that beginning, may need to be reinterpreted entirely. Every time Webb aims its golden mirrors deeper into the universe, the story only grows stranger. Instead of giving us clarity, it's giving us sharper, deeper questions. Instead of closing the book on the cosmos, it's opening new chapters we never imagined existed. Each image, each spectrum, each mysterious galaxy isn't a final answer. It's a cliffhanger, another riddle, another layer of the unknown. Maybe that's the ultimate lesson here. Every time we think the story of the universe is complete, Webb turns the page and shows us there's always more to discover. It's becoming harder and harder to believe we've got the full story. Instead of simplifying the tale of the cosmos, the James Webb Space Telescope has made it far more complex, more unpredictable, and infinitely more mysterious than we ever imagined. So where does that leave us? Right now we're standing at a crossroads in human understanding. The universe we thought we knew is slipping through our fingers. The cosmic microwave background might not be the true echo of the Big Bang. Galaxies are spinning in strange, synchronized patterns that shouldn't exist. And some of the greatest minds in physics are starting to ask a question once dismissed as pure science fiction: what if our entire universe exists inside a black hole? The truth is, the universe isn't a finished equation or a story with a neat ending. It's an unfolding epic with no final chapter, just layer after layer waiting to be revealed. So what do you think? Are we witnessing the end of the Big Bang as the dominant story of cosmology? Are we living inside a cosmic bubble, a black hole in a greater universe beyond our reach? Or are we just scratching the surface of a reality so vast we may never fully understand it? Let us know your thoughts in the comments. We'd love to hear what you think. And if you enjoyed this dive into the unknown, don't forget to like, share, and subscribe for more deep space discoveries. Because one thing's for sure, the cosmos isn't done surprising us. In fact, its strangest secrets may be waiting just beyond the next observation. Thanks for watching, and we'll see you in the next video.